Thanks to all of you for coming. This is a conference about testing, specifically automated testing. But why do we do this? What is the point? What's the reason for all this automated testing? Correctness, of course, is one of the reasons why we test. I loved Paul's comment about confidence. That's one of the biggest reasons I write automated tests. But these aren't the only reasons. They're more the starting point. But what happens when we're doing automated testing really well? What do we get to do next? What's the outcome of that? And I want to talk about that just for a little bit here in my opening session, to get you thinking about, as you go throughout the day and you're looking at the sort of the nuts and bolts and the nitty-gritty of how you're going to do automated testing well, what are some of the things that you can get afterwards? What kind of bonuses can you get from doing automated testing really well? Because honestly, it can be hard. It can be really hard. And it takes time. And whenever you start testing something that you've never tested before, there's a grind of figuring out how to make it work. So it's got to be worth it. And correctness can't be the only reason. Confidence can't be the only reason, although those are both really good reasons. Now, when I started out with software development in the 90s, we didn't do automated testing in the way that it's done today. We had a QA department. We would develop our software. We would throw it over the wall, and they would test it by running scripts. And I don't mean automated scripts. They had the smart QA people who would write the scripts and the monkeys who would execute the scripts. Lots and lots of them. And of course, because we were doing, well, nowadays they call it stage gate development, but back then we called it waterfall development. Because we were doing this waterfall approach, we'd have to do all of our requirements up front, then our analysis and design, and then we'd develop, and then we were out of time. And so, QA would do whatever it could. How many of you lived this back in the day? Yes. Would you like to go back? No? Okay. So, and then in 1994, Kent Beck released S-Unit, not to be confused with Sunit Jadhav, Mr. India 2017, which it turns out if you Google S-Unit, image search, this is what you find. Kent Beck released S-Unit for Smalltalk in 1994. That was the first modern automated testing framework. And not much happened. Smalltalk was not very popular. It was a lot more popular in 1994 than it is now, but it still wasn't all that popular, and it kind of didn't make a ripple. But then in 1997, Kent Beck and Eric Gamma were both living in Zurich. And they were on a plane together to the OOPSLA conference in Atlanta in 1997, and sitting next to each other. And they got to talking about some of the work that Eric Gamma was doing on testing. And Kent said, well, I've done this tool called S-Unit, and they decided to re-implement it in Java. Now, Eric Gamma is famous as one of the authors of the Design Patterns book. And he was heavily into Java. I think he was involved with the Eclipse platform in some way. And they basically re-implemented S-Unit completely in Java, building it from scratch, writing it test first, which was kind of an interesting meta approach. They used a test first approach to write a test first framework. And that, of course, was JUnit. JUnit being the first time that this idea, the XUnit tools, really became popular. This is my computer in 2001. That's running JUnit. That's what it looked like back then. The chicken is what makes it work. You see it's plugged in. If you've done a lot of unit testing or tools like JUnit, you know that sometimes they fail randomly. Apparently through no fault of the programmer or of our own, right? Well, obviously we've done something wrong to make flaky tests, but we always have flaky tests. The chicken was our voodoo chicken. We'd wave it over the keyboard, and the test would pass. Sometimes. JUnit and developer testing, though, didn't really take off until extreme programming came along. You don't hear a lot about extreme programming anymore, but in the early 2000s, it was a pretty big deal. It was the first really popular Agile method. We had major syndicated cartoonists writing about it in the newspaper. I'm still wondering what the average person reading this comic in the newspaper thought of it, but there was a whole series in Dilbert about extreme programming. A lot of what we take for granted in Agile originated in extreme programming, in XP. User stories came from XP, continuous integration came from XP, and of course, test-driven development. Now, how many of you are using test-driven development right now already? Less than I expected. How many of you have heard of test-driven development? Okay, so a lot of people have heard of test-driven development, but there's a lot of misconceptions about what test-driven development is. I was just talking to some folks at a very large company that ought to know better, and they said, we want to do some test-driven development with you. I said, great. Tell me about what you're doing right now. They said, well, we do use test-driven development. First, we write all the tests for our application, and then we write the application. And then, if the tests pass, we're done. I thought, well, that is one way of thinking about test-driven development, but that's not really what test-driven development is. And I find a surprising number of people who think this is how test-driven development works. So I want to take a few moments here and talk to you about what test-driven development really is. Test-driven development is a rapid cycle of forming hypotheses and testing them. It's a tool for continually validating hypotheses. It starts out, in normal development, when we want to develop something, we think, what's the thing that we want to develop? And then we break it down. We're going to do this piece first, and then this piece, and this piece. And then we break that down even further until we say, right now, I'm going to do, this method first, or I'm going to work on this class, or whatever. It's the normal process of breaking down our work until we can actually tackle it. Test-driven development works the same way. We start out by thinking. That's the first step. But instead of then going and writing that first method, that first few lines of code, we actually say, what's the first line of code we're going to write? What are the first few lines of code we're going to write? And what test can we write that would force us to write those few lines of code? Which test can we write that would drive the development of that code? It will fail now and pass when we write those few lines of code that we want to write, and only when we write those few lines of code we want to write. And then we make a hypothesis. We say, I think if I write a test that looks like this, that test will fail. So we write that test, and we say, I think this test is going to fail in this way. We've now made a testable hypothesis. And we run our test, and we see if it fails in exactly the way that we thought it was. And if it does, we're in control of our code. Our mental model of how our system works is correct, and we're ready to move forward. If it doesn't fail exactly the way we thought it was going to fail, then we say, oops, and we back up. And this is really only a few lines of code. And then we say, okay, once we get that working or failing in the way we want it to, we say we can make this code pass by writing these few lines of code. We write those few lines of code and make another testable hypothesis. I think this test will pass because now I've done the thing that I said I was going to do. And we run our test, and if it doesn't pass, if it fails, we go back and we say, what was wrong? And it's usually very easy to figure out what went wrong because we've only written a few lines of code. At that point, typically when we make the test pass, we do it in the simplest, dumbest way possible just to get the test passing. So now what we do is we look at the code and say, how can we make this code better? And we refactor. Now, refactoring, like test-driven development, is a word that gets used a lot these days, but not necessarily correctly. Refactoring doesn't mean typing on the keyboard. That's how I often hear people using the word refactoring. It's not typing on the keyboard. It's not editing code. It's not rewriting code. It's changing the design of your code without changing its behavior. And if you haven't seen it, Martin Feller has a new book out called Refactoring. The second edition of Refactoring. It's been completely rewritten. It uses JavaScript in all the examples. I was one of the reviewers on it, and it's really good. I learned more about design from reading the original refactoring book than I'd learned from anything else, so I highly recommend it. Refactoring is actually a somewhat mechanical series of steps that are supposed to be provably correct, like when you refactor in algebra, when you change a plus b times a plus b to, God, I shouldn't do public math, a squared plus ab plus b squared. That's one factoring of that formula, but a plus b times a plus b is another factoring of that formula. They're equivalent. You can refactor from one to the other, and that's actually where the term refactoring came from. Refactoring in programming is the same. We're changing the way things are structured without changing the behavior, without rewriting. So we go through and we refactor until the code is as good as we know how to make it, or as good as we want to make it today, and then we repeat. And this drives our code forward a couple of lines. This is a pretty fast process. This process, in the red bar step where you're writing the test, you're only writing a few lines of test code, so it only takes 30 seconds, 60 seconds. When you're making the test pass, you're only writing a few lines of code. It takes 30 seconds, 60 seconds. And then refactoring, that takes as long as you need to take. Thinking, yeah, take as long as you need to take. My point here is that test-driven development is less about writing the tests and running the tests than it is about having control of your code and about having a continuous series of provable hypotheses, testing those hypotheses. So I'm going to show you a little video. It's 1 minute and 2 seconds. And the thing that's being developed here isn't super important. What I want you to look for as this video plays is look for all the times where I make a testable hypothesis. That's where I say, I believe this thing is going to happen, and then I do something to validate whether or not that thing is true. So it's not every time that I say, I think. It's not every time I say, I want to do this or I think I should do this. It's when I make an actual testable hypothesis. And when that happens, raise your hand.
I think if we're talking about parsing out an object with a rank, I'm thinking we're going to want to make a card object. So our expected value is going to be a card with a particular rank. Let's say 3. Now, that's going to fail because card doesn't exist. Let's watch it fail. It does.
Just tested that hypothesis. It's going to fail.
Easy to make pass.
Saw it fail.
We'll require it. That will fail because there is no module card. Then we'll make it. And that will fail because there's no constructor. And then we'll make the class. And now it has a constructor, and I expect that will now pass tests.
So how many testable hypotheses did you see in 1 minute and 2 seconds? There are 4 times there. 4 times that I made a prediction and checked if it was true. About every 15 seconds or so, I was able to validate my understanding of the system. And that's what test-driven development is about. It gives us this constant feedback as to whether we're doing the right thing, whether we're in control of our code. Doesn't mean that we're always writing the right code, because it's still possible to be wrong about what we think we should do, but it's really good at making sure that what we think we should do is what we're actually doing. Now, what's interesting about test-driven development and extreme programming, which included, in addition to test-driven development, continuous integration and simple design and evolutionary design and pair programming and all these other things. What's interesting about XP is that the teams that were using it fully, that was really doing it by the book, had really low defect rates. And one of those people was Nancy Van Schrundevert, who submitted an experience report to the Agile conference many years ago now. I was one of the people on the track team for the experience report track. And Nancy's report stood out to me because unlike a lot of the experience reports about Agile, which was saying, well, nobody in the company wanted to do it, and this is how we convinced them that it was a good idea, and these are all the problems that we dealt with in terms of socializing it, we still run into all of that today. Her experience report was saying, hey, we got people to agree to let us do XP, and this is what happened. And she had kind of been pushing to do XP in her company for a while. And so they gave her, they sort of said, well, fine, get off our backs. We're going to just take these folks, do your project. They kind of set her up for failure. She was building embedded software for farm combines, written in C, real-time, multi-processing. And they gave her a team of 4 folks who, various people on the team had never worked in C before, never done real-time systems before, never done multi-processing before, hadn't done embedded. I mean, different people on the project had different levels of experience, but it was very much a team of newbies to this problem domain. They produced 60,000 lines of code over 3 years. They released after 6 months and then supported other teams while they continued to add features to the product over the next 2.5 years. And according to Capers-Jones, who studies software metrics, a best-in-class team working in this environment will produce about 460 defects. So Nancy's team, with a bunch of newbies, how many defects do you think they produced? They produced an order of magnitude fewer defects than the best-in-class team. They produced 51 defects over the course of 3 years. They never had more than 2 bugs in their backlog at a time, and they averaged 1.5 defects per month. This is actually, in my experience, a pretty common result for the teams that were doing extreme programming. And that's one of the reasons I loved extreme programming and why I was so heavily into it when it first came out. XP teams had such good results is that they could release without manual testing. They didn't have that QA department. They didn't do the throw it over the wall. And these kinds of results are part of why test-driven development and XUnit and JUnit became so popular. They could release without manual testing, which means a lot of them would have an automated script. They did continuous integration. That was part of XP. They had an automated script that not only would build and test the software, it would actually burn a release onto a CD. Nowadays, we call this continuous deployment, and we do it to the cloud rather than to a CD. So what can you do when you have this much confidence in your tests? What can you do when you're so confident that when you run that script, if it says go, you can go? Well, for one thing, you can refactor at will. This video is sped up 10 times, so you're going to see it flash every now and then. Every time it flashes, I'm running the tests. This is me refactoring a little problem. So constantly making little changes, running the tests, being confident that it worked, that my code is still good. So you can refactor at will when you have that much confidence in your tests. Little refactorings like this, but also bigger refactorings. This diagram comes from Eric Evans' book, Domain-Driven Design. And in that book, he describes an experience that I find that really resonates with me because I've seen this over and over again. When you're doing a lot of little refactorings, like I showed you in that last video, they sort of build up. You make changes, little change, little change, little change. And then there comes a point where all of these little changes sort of come together, and you're like, oh, wow. There's this thing we can do, this refactoring we could do to dramatically simplify this piece of our architecture. And you do a lot of work to what Eric Evans calls a breakthrough, to make a big change to your system. And that big change makes everything easier. It simplifies your design. It makes it easier to add new features. It lowers your cost of maintenance. And this happens over and over and over the course of your project. It happens every week at the small scale, at the level of a class. Every month or so at the level of multiple classes. And in my experience, it happened for us about every 3 to 6 months at the architectural level. Constantly seeing ways of massively improving our design at each of those levels and making our code simpler and simpler and easier to work with, less and less cost to add features to. If you do this, if you have this kind of ability to refactor, now you don't have to say, what's the thing that we're going to build, and you don't have to do a whole lot of architectural work to make it happen, to support it before you start writing features. Now you can do evolutionary design, which is you can just write the features, the architecture and design you need to support the problem that you're solving today. I'm going to show you a video. This is 25 hours of development on a simple retirement projection tool, doing evolutionary design. So not building any design or architecture more than what we needed for this moment, what we were building actually at that moment. And this was done as sort of an experiment and as a teaching tool. So I checked in my code every 15 minutes. So I'm going to show you in this animation, what you're seeing is every 15 minutes how the design changed. So it went from basically nothing to having the ability to do simple projections in memory to having a full UI with full GUI with tables and so forth. Then that was only 25 hours, and it went on from there. If you can do this, if you can build only what you need for the problem you're solving today, you can spend a lot less time worrying about architecture, thinking about what do I, setting all this stuff up before you start developing. There's a company that most of you have probably never heard of called Writely. Many years ago, tried to build a competitor to Microsoft Office, which may not seem like the smartest thing to do. They built it as an online tool, and I don't have the inside details of how they wrote their application, but I suspect they did something like this, because they shipped the first version of Writely 2 weeks after they started developing. So they could not have done a big, hey, let's solve all the cloud problems, let's solve all the concurrent editing problems. They could not have done that and still shipped in the first 2 weeks. Now, of course, you haven't heard of Writely, so you might be thinking, well, so what? Who cares? Obviously, it didn't work out for them. Actually, it did. The reason you haven't heard of Writely is because they were acquired by Google. Now they're called Google Docs. So if we don't have to build a lot of architecture before we start implementing code, we waste a lot less when we change our minds. And that means that we can start to embrace change. We can experiment with the best ways to meet the needs of our users and our business. Now, of course, people like their predictable plans. They have this big, fuzzy, unknown future, and they liked having this bright, shining line. This is the way we're going. Follow me. But that doesn't always work out. My wife and I, when we got married, my wife's Canadian, as I said, and she was getting her green card in the US. And so we couldn't leave the country, but we wanted to go somewhere a little different for our vacation, for our honeymoon. So we chose to go to Hawaii. It's kind of the cliched honeymoon. And it did turn out that when we were on the plane to Hawaii, one of the flight attendants said, so who here's on their honeymoon? And half the plane raised their hands, which made it feel a lot less special, to be honest. But we had never done a trip this big or complicated, and so we decided to plan it all up front, very meticulously. We went to a travel agent who did nothing but specialize in Hawaiian vacations, and she interviewed us and said, well, would you like to do a romantic stargazing in the evening? We're like, yeah, that sounds great. How about a romantic mountain bike ride down the side of a mountain into the sunrise? Yeah, that sounds great. So we gave her a whole bunch of money, and she gave us back this little booklet of coupons that we were going to use to do all of our stuff. And it was all planned out perfectly. But the problem is these big upfront plans tend to have a challenge when they meet the real world. As the reality comes along, you see that there were other choices that you weren't even aware of, and the best outcome is not exactly where you were aiming. It might be close, but it's not going to be exactly where you were aiming. What happened with us is that, for example, when we when we got to the big island of Hawaii, it turns out that our reservation, which had been made months and months in advance, had gotten lost. Because it had been made months and months in advance, this happens with hotels, especially smaller hotels. And they were going to put us in the military barracks, which is not what a honeymooning couple wants to hear. I mean, it was nice of them to try to find a spot for us. So we were kind of in a funk, and we started driving around the island, seeing what kind of other options we could find. And we came across this place that had a bed. There was a bed and breakfast, but the room was in a tree. It was a tree house bed and breakfast. And we thought, this is the coolest thing ever. But we had this big booklet of prepaid things. All of it, everything was already prepaid. So we decided to go back to the volcano house and see if they could figure out a reservation, which they did. I guess they kicked somebody else out because they were full, put them in the military barracks. But it worked out. But I kind of still regret not being able to do that treehouse B&B, because that would have been really, really cool and exciting. So that evening, we were doing our romantic stargazing, and we looked at where it was, and it turns out the big island is called the Big Island of Hawaii because it's really big. And so we had to drive around the island to basically the exact opposite point. So we spent 2 hours driving around the island. We got in a van with a bunch of other people, and the van drove over these gravel roads up the side of a mountain, and to where we could do the stargazing. It was the observatory, but we didn't get to go into the observatory. They pulled some telescopes out of the van. And we went outside, and we looked at the stars, and we looked through the telescope. Oh, it's beautiful. It's really cold. So we got back into the van, warmed up for 5 minutes, went back out. Oh, it's beautiful. Oh, it's cold. Back in the van. Did this for a few hours. And then back down the side of the mountain, across the gravel roads, back out towards the edge of the island, or back to where we left our car. 2 hours back the other way for variety, back to where we were staying. We got back to our hotel. I think it was about 1 a.m. or something like that. We're like, well, that was nice. Let's sleep in tomorrow. But first, we had to look at our book of travel vouchers. And the travel vouchers said that tomorrow morning was our romantic bike ride down the side of the mountain into the sunrise. The same mountain we just came from. The sun rises early in the tropics, or it sort of comes up suddenly. I don't remember the exact details, but I want to say that in order for us to get there on time, we'd have to be awake at 4 a.m., and it was 1 a.m. now. So we lost that money. The plan was made, but we didn't go, and the coupon just got wasted. And this is what happens when you make your plans in advance. So on our next trip, we planned to adapt. Instead of saying, here's everything we're going to do, we said we actually were going to go on a month-long backpacking tour of Europe. And we said, well, there's no way we can plan a month and have it go anywhere near well. So what we did was planning is super important, but adapting your plans, but you have to be able to plan to adapt. So we got a good buy book. We made sure our phones had email, so we could email for reservations. We got plane tickets and rail tickets because they get more expensive. We knew where we were going to land and where we were going to end. But other than that, we just had an idea of where we were going to go. And the way it worked is we'd arrive in a city, we'd drop off our bags in the hotel that we were in, and then go out and explore the city. A couple of days before we were ready to move on to the next city, we'd go to the train station, choose a destination, email the hotels, pick one, find one, get a reservation, and then a couple of days later, we'd leave and go and start the whole process over, drop off our bags, explore the city, have a great time. We had the same kinds of problems that we had in Hawaii. When we got from Italy, we were thinking about going to Greece, but when we got there, we discovered there was a 24-hour ferry ride from Italy to Greece. So we went to Switzerland, Amsterdam, and Sicily instead. My wife's cousin lives in the UK, and she called us and said, I've gotten engaged, and we're going to Sicily to celebrate. Do you want to join us there? So we said, sure, we can change your plans, and we flew down to Sicily and celebrated their engagement together. It's not to say it wasn't without issues. Early on, we went to a little town in France that my wife had fond memories of called La Rochelle. This was before we realized we needed to book all of our rooms in advance. And so there were no rooms available. And we went around to various hotels begging them to let us in. And we finally found a room. But it was overlooking the harbor where all the festivities were happening. It was super noisy. So we shut the shutters and went to bed. Half an hour later, woke up because it's stiflingly hot in the room. So we open up the shutters, go back to sleep, cannot go to sleep because it's super noisy. So we shut the shutters, wake up half an hour later. We did this off and on until the early hours of the morning, 1 or 2 a.m. Finally fell asleep, and then at 5 a.m., the garbage truck started coming by. Woke us up. So we were on the first train out of there because we didn't have a fixed plan. We were on the first train out of there. We chose Provence. We emailed on the train, can we get a hotel? They said, sure. We got there, we crashed, and we woke up to the sound of rain, what sounded like rain on the rooftop. We rubbed our eyes blearily. We looked out the window, and it's sunny. So we go out to our little balcony, and this is what we see outside. What we thought was rain was actually the sound of hooves. There was a non-lethal bullfight happening right outside our window. And this is what happens when you can adapt your plans. You got this big, fuzzy, unknown future, and as things go along, you have to experiment. You have to test ideas. Some of them will work out, some of them won't, but this is how you can get closest to the best results. This is thinking in tests. Conduct experiments, get feedback, learn, and adapt. Tests don't make this happen, but they make it possible. Thank you.